Namaste and welcome back to the video course on watershed management. Today in module number 10, lecture number 40, the last lecture, we will discuss about water reclamation and reuse. So, some of the topics covered today include reclaimed water, reclamation processes, reuse of water, then summary of the course. So, keywords for today's lecture include water reclamation and water reuse. So, as we are discussing in the last two lectures, water conservation, water recycling and water reuse is very important aspects as far as water saving is concerned, or wherever water scarcity is there, the way which we can go ahead is conserve the water, use very effective way the water or most efficient use of water, and then recycle or reclaim the used water and further reuse. So, that should be the way we can say go ahead with the available limited resources, so that we can have the best utilization of the water. So, when we look into the reclaimed water, so reclaimed water or recycled water, as we were discussing in the last lecture. So, it is former waste water, so treated to remove solids and certain impurities and used in sustainable landscaping, irrigation or to recharge groundwater aquifers. So, as we are discussing in the last lecture, we can use this reclaimed water, recycled water, say mainly for non potable purposes, say such as say irrigation purpose or the some industrial purposes or some domestic purposes like say flushing toilets like that, or say some of the type of potable use, but through maybe by recharging to the aquifer systems as groundwater recharge, or we can say send this purified water, reclaimed water to the surface water sources, which we can further utilize. So, we can mainly use the reclaimed water for non potable purposes, but sometimes if the water scarcity is there, we can further use the reclaimed water for say potable purposes also through groundwater recharge and other ways. So, that way when we look into the reclaimed water, the main purpose is sustainability and water conservation rather than discharging the treated water to surface waters such as rivers and oceans. So, as we know that the wastewater treatment without treating many locations, as we were discussing some of the lectures also earlier. So, water quality is a problem, so water pollution is a major problem. So, especially industrial or the municipalities, when they send the wastewater without appropriate treatment to the surface water sources like lakes, rivers or to the sea, then the existing say natural water will get further polluted, and this wastewater disposal is a major issue. So, that way when we look into water reclamation or the water recycling and then reuse, we can see that say we are trying to conserve the water, and then further as far as water as a resource is concerned, say it become more sustainable, and then say we can see that the amount of wastewater, say if we are reclaiming the wastewater through recycling, then the amount of wastewater to be treated or to be sent to the surface water sources like rivers, lakes or the sea become reduced. So, that way we are getting environmental benefits also. So, that way it is economical also. So, when we look into reclaimed water, we can see that end product of wastewater reclamation meets water quality requirements for biodegradable materials, suspended matter and pathogens. So, so that say the uses such as agriculture and industrial uses we can meet with respect to the reclaimed water. So, when we look into the reclaimed water, we have to see that as we were discussing the last lecture also, we have to see what is the use, what is the intended purpose or the use using that reclaimed water, and then what is the source of that the wastewater coming from, say whether it is coming from domestic sources or industrial sources, how much treatment to be given. So, we have to work out say what kind of treatment to be given and what type of reuse will be possible. So, accordingly we have to see the type of use, type of reuse as far as the wastewater is concerned. So, now when we look into the reclaimed water, say for maximum water use or reclamation or recovery. So, we have to select appropriate strategies. So, strategies such as water pinch analysis. So, water pinch analysis is an analysis which is done in many countries. So, it is actually a systematic technique for reducing the water consumption and wastewater generation through integration of water using activities or processes. So, this water pinch analysis is a scientific method so that we can identify how much water is to be reclaimed or how much water is coming as wastewater, and then how we can go for systematic technique of reducing the water consumption and the wastewater generation. This kinds of analysis like water pinch analysis helps a user to target the minimum freshwater usage and the wastewater target. So, water pinch analysis is important as far as when we look into water conservation and then wastewater generation, wastewater treatment with respect to all these things. So, that way this kinds of analysis helps in designing the network that achieves the target. So, the target is the efficient usage of available water. So, that we want to use the less water as far as the consumption is concerned, so that wastewater generated will be also less, and then that way we can conserve the water, and then we can choose appropriate methodology for reclaiming or recycling or reuse. So, as far as the cost of reclaimed water, say when it exceeds that of potable water, so in many regions of the world. So, we can see that say most of this wastewater, when we have to give appropriate treatments that will suit say to the standard of potable water, then we have to go through say not only primary or secondary but tertiary treatment, and then say nanofiltration or the reverse osmosis, that kinds of processes as we discussed in the last lecture we have to give, and then the cost of the reclaimed water go up. So, that way we can see that in many locations, so the cost of reclaimed water may exceed the available natural potable water. So, that way we can see that when we use the reclaimed water for non-potable uses, so say if we can use this reclaimed water for non-potable uses like industrial or domestic purposes or agricultural purposes, we can save the potable water for drinking, and so that way say the whatever we have to use for other purposes, the potable water which we are using, that can be reduced by using the reclaimed water. So, that way we can save the water, and then usage of water reclamation decreases the pollution sent to the sensitive environment. So, as we are discussing, so when we are reclaiming or recycling the wastewater, so actually the amount of wastewater to be treated and to say before disposing to these surface water sources like rivers or the ocean. So, that way the amount is reduced, and then when we are reclaiming the water, so that way also we can say benefit. So, that way we can see that when the usage of water reclamation decreases, usage of that decreases the pollution, the polluted water sent to the environment. So, that way say it is as far as the wastewater reclamation is concerned, say when we are using, that way we are saving, plus the amount of wastewater we are reducing. So, that way also we can save. But say if potable water is available as a cheap source, then we can see that while going through these kinds of reclamation or recycling, the cost may exceed. But anyway, when we look into industrial processes or urban areas or cities, we can see that this recycling is a good option, or reuse of the reclaimed water is a good option, as we were discussing in the last lecture. So, when we try to reuse the reclaimed water, number of concerns are there about say whether it is whether we are going for non-potable purpose or potable purpose. So, we have to see all these concerns. So, let us look into what are the important concerns when we look into reclaimed water and its reuse. So, reclaimed water is highly engineered for safety and reliability, so that the quality of reclaimed water is more predictable than many existing surface and groundwater sources. So, we say the water recycling or water reclamation process. So, it is a systematic process through which we have to send the wastewater through various stages, and then we can see that we can predict what will be the quality of the reclaimed water which we have to reuse for various purposes. So, that way this reclaimed water is a highly engineered water. That may be sometimes more pure than the natural water available from the existing surface sources or groundwater sources. That way we can see that when reclaimed water is safe when appropriately used. So, as I mentioned, we have to see the intended use of the reuse of the wastewater, and then we have to give appropriate treatments accordingly. So, reclaimed water say planned for use in recharging aquifers or augmenting surface water receives adequate and reliable treatment before mixing with natural water and undergoing natural restoration processes. So, especially if we are planning to use this reclaimed water say for potable purposes or recharging to the aquifer systems, or to the when we are discharging to the natural source of water like rivers or lakes, we should be very careful, and then we have to see that it meets the required standards, and then reliable treatment is given before mixing this reclaimed water. And then some of this water eventually becomes part of drinking water supplies. So, we can see that say especially say let us assume that there is a long river and then number of cities are there say at different parts of the river. So, then we can see that most of the time what happens, say the cities on the upstream sides, say they take the water from the river and then use it, and then after treatment they put back the effluents to the river again, and then the downstream sides again cities will be there, and then they are again drawing this water for their purposes. So, that way we can see that this water say in many of the water supplies of many cities, especially on the river sides, we can see that they are reusing the water. So, the water used by one city will be again reused by another city on the downstream side. So, that way when we look into reclaimed water, it is often distributed say, or it is we have to take care when we look into these kinds of say the effluents what is coming to the natural systems. And then say in a township or in an area when we are trying to reuse the reclaimed water, it is often instead of mixing this say if we are directly going to utilize the reclaimed water, it is always better to have a dual piping system, piping network, so that the intended purpose of this reclaimed water, say for example, if it is for irrigation or if it is for say flushing systems. So, like that it is always better to send this reclaimed water through a dual piping, especially if we are directly going to utilize the reclaimed water. So, that this the reclaimed water pipes completely separate from the potable water pipes. So, the user should not get confused with the potable water pipes and the reclaimed water pipes. So, that we should have a dual piping systems network, and then the consumers should know which is the reclaimed water and which is the potable water. So, like that. So, then say now let us look into what are the reclamation processes. So, in the last lecture also we were discussing about the water recycling. So, we were discussing various processes, we have discussed in detail about these processes. So, anyway we will have quickly go through say some of the important processes where the water reclamation or water recycling which we have discussed in the last lecture also. So, as we discussed in the last lecture, so first one is say once we collect the wastewater, so we have to give some preliminary treatment like we can send this collected water through bar screen so that the solids can be removed. Then the next stage is primary treatment like we can have settling tanks, so that the readily settleable and floatable solids are removed from the wastewater. And then sometimes we can use some type of biological treatment. So, using microorganisms, bacteria which digest the sludge, and reduce the nutrient content in the wastewater. And then say we can have the secondary kind of treatments like settling tanks and trickling filter and all those things what we are discussing in the last lecture. So, here in the secondary treatment, microorganisms to settle to the bottom, other small particles suspended in the water are picked up, leaving behind the clear wastewater. So, many of the agriculture purposes we can use the reclaimed water from the secondary treatment, we can directly go for reuse, and also some of the industrial process directly we can utilize after the secondary treatment. And then if you want more purified form of the water, say reclaimed water, then we have to go for the various tertiary treatment which we discussed in the last lecture, like deep bed, single media, gravity sand filters, and then receive water from the secondary basins and filter out the remaining solids, and then we can send the reclaimed water through say like filters like ultra filtration, nano filtration, or say reverse osmosis, so that the most say purified form of the reclaimed water is obtained. So, like that whatever they depending upon the intended use, say after secondary treatment or tertiary treatment, we can directly reuse the reclaimed water. And then especially if we are going for say potable or other kinds of uses, then disinfection is also required, like we can mix the water after the tertiary treatment with chlorine contact tanks within the chlorine contact, and then that way we can disinfect also the reclaimed water. So, that way we can directly say reuse the water, say even sometimes potable purposes if the sufficient potable water is not available in the considered area. So, now let us look into the say with respect to we are discussing about the reclaimed water, its processes, and now let us look into the concepts of reuse of water. So, we were discussing the recycling and then reuse. So, where we can reuse the particular type of water, and then how we can reuse. So, the concept of reuse of water. So, as we are discussing, reuse is most applicable where large volumes of water are reused and waste are not too wastewater is not too contaminated. So, say the water coming from say especially say like cooling processes. So, the water is not much say contaminated. So, that way we can directly reuse it, or say the waste the contamination in the water is say much less, say through after say washing or some of the processes, then reuse is most applicable. And then location of treatment plant and possible transport of renovated water. So, these are some of the important consideration when we look into the concept of reuse of water. So, we have to see that say we collect all the wastewater and then give appropriate treatments, and then we have to see that say it is sent to or transported the renovated water to appropriate locations for reuse. So, now other concerns like the treatment processes. So, as we are discussing earlier, so what type of intended use. So, accordingly we will be giving say primary, secondary or tertiary type of treatment or the modern treatment. So, but we have to see that the economics also. So, the benefit cost analysis we have to do, and then we have to see that benefit say the whatever we are spending it is beneficial. So, efficient and economical when flow is steady. So, especially treatment processes. So, if the say we have to see that sufficient wastewater is keep on coming as a source of wastewater when we are sending this wastewater for treatment through the treatment plant for reuse purposes. So, that steady flow should take place. But we can see that especially say wherever we go for this kinds of water reclamation or wastewater recycling. So, most of the urban areas is the flow will be regular. So, when say especially for domestic sector is concerned, we can see that more water is used in the morning hours and in the evening hours. So, in between or in the night time we can see that there will not be regular supply. So, that kind of problems are there. And then now say as far as wastewater reclamation is concerned, we have to give appropriate treatment or processing before making it reusable. So, this issue we have already discussed in the last lecture. Then water reuse is concerned, so we have to see the use of treated wastewater for beneficial use. So, say for example, say after secondary treatment, say for the wastewater, say good amount of nutrients will be present within the secondary treated water, wastewater. So, that will be maybe more beneficial for agricultural or irrigation, since the plants get say nutrients from this water source. So, like that we have to see the beneficial use as far as the water reuse or the wastewater reuse is concerned. Now, say as far as the reuse is concerned, we can have either direct wastewater reuse or indirect reuse. So, direct wastewater reuse requires pipes or other conveyance facilities for delivering the reclaimed water. So, most of the time we need the dual system where the reclaimed water, another piping system through which we can send this reclaimed water. So, that is for direct wastewater reuse. So, that may be for irrigation or agriculture or flushing or maybe some of the industrial processes. Now, second one is the indirect use. So, indirect use, say here we are discharging the effluent to receiving water for assimilation and withdrawals downstream. So, indirect use means, say for example, say as I mentioned earlier, say if two or three cities are there, different location on the sides of a river, then we can see that upstream city, so that what will be withdrawing the water, and then after their use, say after treatment, the wastewater as effluent will be coming back to the river, and then through natural processes this water will become again reusable for the next city. So, like that indirect use takes place. And also, say if we are recharging the treated water to the aquifer systems, so then again that water will be pumping back for the direct say other use. So, that way we can say that there is indirect use. Then say industries like pulp and paper industries, say water reuse is predominantly practiced. So, through various processes, from one process to another processes, the effluent coming from, they give some kinds of treatment, and then again they reuse for the other process. So, like that say especially pulp industries, textile industry, paper industries, say this reuse is very common. And then as far as domestic reuse is concerned, so best recycle opportunity, but amount of water recycled falls short of the total amount of water reused. So, domestic reuse is concerned, wherever water stress or water scarcity is there, we can keep on reuse, but of course, there will be some shortage, since the consumption or other purposes, say some water will be lost in between. So, say we have to see the best recycle opportunity as far as domestic reuse is concerned. And then warm and dry areas, say the reuse is suitable for domestic reuse, where there is a large difference between supplied water and wastewater due to losses. So, especially warm and dry areas, we can see that evaporation and other losses will be much more. So, that way if the water sufficient natural water is not available, potable water is not available, we have to look into the reuse concept. So, when we look into reuse, say the concept of reuse is concerned, say we can, as we were discussing in the last two lectures, say as far as the water recycling, say we can either say use the rainwater, the storm drainage water, or the grey water which is not much polluted, and then the sewage water. So, these four categories of water is available for reuse. So, actually the first two categories, say less risk and then preferred options, say like rainwater use or the storm water use. And then grey water or sewage water is say high risk and least preferred option, especially for domestic purposes. And then especially rainwater and storm water, the reuse, the advantage is that it is low energy requirement, so no need of much treatment, we can directly utilize but as far as the sewage water or the grey water is concerned, we have to go for high energy type requirement, and then we have to go for various kinds of treatment. So that way we have to see what type of reuse we are looking for and from what source we are looking for the reuse. Then as far as reuse of water is concerned, say with respect to the quality of water, say and the time sequence, say for example unpolluted water we can directly use for drinking, then say through after some appropriate water treatment. And then as far as the municipal and industrial use is concerned, directly the wastewater will be coming, and then that wastewater we can treat appropriately, and then water reclamation or recycling is possible, and then further reuse is possible. And then say after this wastewater treatment, the treated effluent, and then we can reclaim the water and then repurify and further utilize. So this is the quality changes of during municipal use of water and concept of wastewater reclamation and reuse as given by McGuhay in 2006. So when we look into water reclamation and reuse, so water treatment for drinking water, say we have to meet appropriate standards. So as we are discussing, say the pH range like 6.5 to 8, or the TDS requirements, or the BOD or COD, all these kinds of requirement we have to see, especially if we are trying to use the reclaimed water for drinking purposes, we have to go for strict measures for quality control. Then say especially if you want to reuse the municipal and industrial water, so that is much degraded water, so the quality issues are there, and we have to go for appropriate waste treatment. So the treatment is carried out to the point required by the regulatory agencies. So what kind of treatment to be given is especially for drinking or other purpose, we have to see as per the norms of the regulatory agencies for protection of other beneficial uses. So here in this figure, say when we look into this, say the dashed line in the figure represents increased quality for reuse, and the concept of reclamation and reuse will come after the wastewater reaches the natural unpolluted water. So if the reclaimed water, if we are putting to natural unpolluted water, then how the effect, all these aspects we have to study appropriately, then only we can send this effluent to the natural water sources, from which if we are directly say using the water for various purposes, we have to see the standards are kept as far as the reclaimed water that will be mixing with the other source of water. So that way we have to see the repurified water, I mean the water reclaimed and then again purified. So the water generated by further advanced wastewater reclamation technologies, say like carbon adsorption, advanced oxidation and reverse osmosis. So as we are discussing the last lecture, say many of these advanced treatments, the water become much more purified form and generate much higher quality than the conventional drinking water what we are directly taking from the rivers, lakes and other sources. So the character of wastewater entering in renovated plant is important, and especially industrial wastewater is concerned, we have to see which way the treatment to be given and what kind of reuse we are looking for. Say for example ordinary salt brines, and then these undesirable for if the renovated to be demineralized, say the uses not the water should not have much mineralized this thing, say the water say if you are going to reclaim from the salt brines, and then say if you have to remove all the salt content from the reclaimed water, then it will be much more expensive, and then so that way we have to see the cost of the reclaimed water. So when we look into reuse of water, then various schemes we can see that say the reuse from the various sources. So as we are discussing the source, we have to see like rainwater, drainage system, sewer systems, etc. Then the particular schemes we have to adopt depends upon the intended reuse as we discussed earlier, and the reuse of wastewater is concerned. Say when we are looking to the reuse of wastewater, we have to see the source of wastewater, whether it is coming from the domestic source, industrial source, whether it is say whether it is highly contaminated, or whether it is only only some TDS or so small kinds of type of pollutions are there. So we have to do appropriate survey of the sewer system for finding wastewater availability for reuse. So when we look into the reclamation water, wastewater reclamation and reuse, so say in a particular area, we have to study the system, we have to study the quality of the wastewater coming. So we have to collect the samples from the various sewer systems, and then we have to identify the parameters within that wastewater. So before going for appropriate treatment that is to be given for the wastewater. So highly contaminated wastewater with metals or containing high total concentration of dissolved solids, generally these are unacceptable for most of the uses, especially domestic or industrial purpose are concerned. Then deliberate use of treated wastewater in planned way is important. Say as we are discussing some of the case studies like the Rashtriya Chemical Fertilizers Mumbai in Chembur plant. Say they are deliberately using the treated wastewater for their industrial processes. So so that way they know the quality of the wastewater, and then accordingly they have put a system of treatment as far as the reuse scheme is concerned. So that way when we look into the reuse schemes, water reuse schemes, we have to study the sewage water, at various locations like main sewer. Then the main sewer may be the wastewater may be coming from the domestic sources or industrial sources after treatment. Then sometime we can directly, say if not much polluted, we can directly put into the wastewater treatment plant. Then we have to, after the treatment, we have to send that water for reuse, and then from the treatment plant, say the sludge is returned back to the main sewer, which will be again further mixed with other highly polluted wastewater, say like which is not suitable for reuse, and then all this mixture will be sent to further sewage treatment, and then the treated effluent will be sent to the natural sources like rivers, lakes or oceans. So that way when we look into the water reuse schemes, we have to study the various aspects like the quality of the wastewater, from where we are taking the wastewater, and what kind of treatment to be given, and then what will be the intended reuse. So like that we have to plan the reuse schemes. So when we look into reuse schemes, say we can see, as I mentioned, it can be unplanned reuse schemes or the planned reuse schemes. So unplanned reuse schemes, as I mentioned earlier, cities draw water supplies from rivers that receive wastewater upstream, and then water from these rivers are reused, treated and piped into the water supply a number of times before the last downstream user, say last city, withdraw the water. So that way, especially on the banks of the rivers, same long rivers, we can see that a number of cities will be there on both sides. So that way we can see that these are all unplanned. So the cities are developing, and then they need water, and then that way say we cannot plan say in advance. So this is called unplanned scheme. Reuse schemes. So then planned scheme is, say especially for an industry is concerned or particular locality is concerned, we can identify the quality of the wastewater, and then we can go for appropriate treatments and then beneficially reuse the recycled water. So that way the water reuse may be for then accordingly whether it is unplanned or planned, we have to see the intended use, especially the planned use may be for agriculture purposes or industrial or domestic purposes. So especially for agriculture purposes are concerned, for agriculture reuse, say we may have to go for primary and secondary treatments as we discussed in the last lecture. Industrial or domestic purpose are concerned, we may have to go for tertiary treatment also, and then to remove the more residual pollutants, especially the dissolved and refractory substances and microorganisms, depending on the intended use as far as the reuse is concerned. So that way, when we look into the reuse schemes, whether it can be a unplanned reuse scheme or the planned reuse scheme, so accordingly we have to go for the treatment and the reuse. So now let us look into the different types of wastewater reuse. So the reuse of urban wastewater in agriculture and horticulture from sewered areas. So as we were discussing earlier, we can give some primary or secondary treatment, and then directly we can reuse it. And then reuse of urban wastewater from polluted nallas draining unsewered areas. So there the wastewater will be much more polluted, and then we may have to give more treatment depending upon the intended use. And then reuse in industrial and commercial establishments to meet the water shortage. So as we are discussing some of the case studies earlier, we can even collect the wastewater and then send to appropriate treatment plants, so that the concerned industry get sufficient water through this process of water reclamation and reuse. So that way, say nowadays we can see that many of the industries are looking for zero discharge. So whatever the water they are using, they are keep on reusing through reclamation, various reclamation process. Finally, there will be only sludge will be sent for further waste treatment. Otherwise, say some of the industries can achieve the zero discharge. So now, say as a part of environmental sustainability, the major motto of the most of the industries is to achieve the zero discharge level. And as far as reuse is concerned, for major urban and community development purposes, say we can use the wastewater as example to augment the public water supply. So like through recharge to the aquifer systems, or after appropriate treatment we can put this the effluent, the treated wastewater which is in a good form, and we can as a good form of the water that can be sent to the water sources like rivers, lakes and the aquifer systems. So as far as reuse in industries are concerned, so say some of the typical strategies followed by the industries here I have listed. Say first one is, of course, most of the industries are looking for water conservation. So most efficient use of the available water, and then reduce the usage is concerned, as we were discussing in one of the previous lecture. So firstly, practice as much conservation of water as possible. So that is the first aim of the industries. And then secondly, recycle the fraction of wastewater which is in relatively good condition and can be recycled back with a little or no treatment. So that way the industries can save a lot of money, since if they have to buy again fresh water, that will be more expensive. So if they can recycle with some treatment of the water, then that can be with little or no treatment, that can be directly utilized for other processes. Then thirdly, we can arrange for more reuse after some treatment to make the industries own wastewater fit for reuse. So the third aspect in reuse in the industry is concerned, they have to collect all the effluent or the wastewater coming from various plants, and then they have to give appropriate treatments and reclaim the water, and then go for the reuse. And then finally, as we discussed in some of the industrial plants like RCF in Mumbai, if more reuse is needed, get the external source of wastewater, say from the municipal corporations, they can get the wastewater, the municipal sewage can be obtained. Some of the industries in places like Mumbai and Chennai, they are doing this, they buy the wastewater from the municipal corporations, and then they give appropriate treatments, and then that can be reused. So that way the reuse in industry is concerned. First one is water conservation, second one is say the recycle with water with relatively good condition without much treatment. Third one is their own reclaimed water through appropriate treatment, reuse. Then lastly they can get the wastewater from the municipal corporation and then reuse. So, as far as the water reuse in India is concerned, we have discussed two cases in the last lecture. So, again here two more examples I have put here. So, water reuse in India, say first the Madras, first example is Madras Refineries and Madras Fertilizers Limited, Chennai. So, Madras Refineries is producing about 12 million liters per day of reusable water, and then Madras Fertilizer is producing about 16 million liters per day of the reusable water since 1991. So, through various processes they are treating this their own wastewater, and then they are recycling it and then reusing it. Here the Chennai Met also these industries say whatever the scarcity of water is there, they buy the wastewater from the Chennai Metro Water Board, and then the water board supply the water after secondary treatment. So, about 120 milli which has about 120 milligram BOD, and these industries get this water and give appropriate treatments depending upon their end use. So, like say they get the secondary treated wastewater, then they go for additional secondary biological treatments, then like chemically aided settling plus pressurized filtration plus ammonia stripping, then carbonation, clarification, then pressure filtration, then chlorination, then sodium bisulfate dosing, then multimedia filtration, then cartridge filtration, then reverse osmosis, and then they permeate the water for reuse. So, these kinds of say flow chart is used for their own wastewater or the wastewater obtained from the Chennai Metro water. So, that way what I want to say is that say depending upon the intended use, depending upon the quality of the wastewater or the contents of the wastewater, we can have appropriate treatment process, and then we can reuse that wastewater. So, this is example 1, and in second example, so here another Vadodara pilot plant in Gujarat. So, this plant uses highly polluted wastewater from an effluent disposal channel into which several industries such as refineries, fertilizers, petrochemicals discharge their raw waste with a capacity of 3 million liters per day fresh water. So, this plant actually they are collecting the wastewater which is taken from a nala or a channel, waste disposal channel, and directly they are giving appropriate treatments, and say the capacity is about 3 million liters per day. The plant shows that at least 75% of the wastewater could be made reusable at an operating cost of rupees 36 per 1000 liter. So, after doing all these treatments, it has shown that the cost is only about rupees 36 per 1000 liters. So, the flow sheet adopted in the plant include the following treatments, like the collection of wastewater, then say it goes through a chemical feeds like lime, polyacrylic or soda ash depending upon the water quality. Then it will be sent to clarifiers. So, then clarification, and then some say HCl treatment is given, and then it will be sent through pressure filtration, and then it will be sent through sodium biosulfate treatment, and then further cartridge filters, either ultrafiltration or nanofiltration or reverse osmosis will be done, and then to remove the carbon dioxide degasification is done, and then further the purified water is reused in the industry. So, again here you can see that this industry is concerned, it is not using their own wastewater, but they are collecting the wastewater from the external sources and then go through a series of treatments, and then that water is used in the by the industry. So, that way we can see that they are having they do not need further fresh source of water, but even the wastewater they are giving appropriate treatments and then reusing for their intended use. So, that way we can see number of cases of water reclamation and then reuse in India and other parts of the world. So, as we discussed earlier, the water reclamation or water recycling is increasing, say to say a range of about 10 to 15% per annum, and then say the reuse is also for various purposes, and with ultra modern techniques. So, even the recycled water, reclaimed water, we can directly even supply for drinking purposes. So, that way finally, before concluding this part of the lecture, let us look into the future water reuse. So, due to the water scarcity or the water stress, as we have seen earlier also, water reuse is increasing. So, reuse can be through recycling, reclamation, and that in many cases have been found to be effective and very successful, and the cost of the initial investment to be done, that many of the industries are getting back in 3 or 4 years of time. So, especially the reclaimed water is mainly reused for non-potable purposes like agriculture, irrigation or industrial processes, that is widely accepted and practiced all over the world, and then this percentage is increasing, say, to the range of 10 to 15% in many parts of the world. And then as we discussed in the last lecture, more advanced technologies are available for recycling and reclamation, like nanofiltration, then reverse osmosis. So, that way we can produce much better form of water, purified form of water, that we can even use for potable purposes. But of course, that may be more expensive. So, we have to see that the intended use and then quality of the contents of the wastewater, and then give appropriate treatment. And also, as we discussed, indirect potable reuse is possible. So, like instead of directly supplying for potable purpose or domestic purposes, we can put this treated water maybe after tertiary treatment for recharging the aquifer systems, or that treated water can be mixed with the fresh water sources like lakes and rivers, and then we can utilize. So, that is the indirect potable reuse. So, that way we can see that as we discussed earlier, recycling, reclamation and reuse. So, it is more energy efficient, since the money we had to spend for say treatment of the wastewater before putting to the as an effluent to the natural sources. So, that we can save. That way we can see that in many cases this will be more energy efficient. And then sustainable water management we can achieve through the recycling, reclamation and reuse. So, especially when we look into watershed management in a sustainable development way, we have to look into the possibility of water recycling, water reclamation and water reuse. So, that is a very important aspect as far as watershed management is concerned. So, moreover, now the public, the people participation is also essential for recycling and reuse. So, that way the people should know the advantages, its limitations, and then they should aware that say where these kinds of the reclamation or recycling can be done, and then what are the intended use of the reclaimed water. So, like that. So, that way the future of water reuse is much bright, and then more places, more industries and more cities are going for water reuse, water reclamation and water reuse. So, some of the references used for today's lecture here I have listed as in the previous lecture also. So, these are some of the important references used for today's lecture. And some of the tutorial questions with respect to the water recycling and reclamation and reuse, what we discussed just now. So, critically analyze and study the scope of water reuse in India. Do the urban water scarcity can be reduced by reuse of water, and study and compare various case studies available on reuse and evaluate the benefits and costs. So, here this reference can be a number of cases are given, and also in websites, US EPA website, and then also this website, and then also CSE publications, these details are available. Then few self-evaluation assignment questions. Describe the importance of reuse of recycled or reclaimed water. What are the important reclamation processes? Illustrate the water reuse schemes. discuss various issues related to water reuse in industries. Then what are the main concerns about the reclaimed water, illustrate the concept of reuse of water, describe the types of wastewater reuse, and which are the places where reuse is possible. So, all these questions can be answered with respect to the lecture just now, say this lecture. And now, as this is the last lecture as far as this say video course on watershed management is concerned, let us have a quick look into the what we have covered. So, let us have a summary of the topics covered, and then let us conclude this lecture. So, the summary of the course on watershed management. So, here say in the first lecture I have given the objectives of this course, and then the various modules which will be covered also given. So, as I mentioned in the first lecture, here my main aim of this lecture is to introduce watershed management and establish its relevance and concepts as far as this watershed management is concerned. And this lecture presents the fundamental principles, theories, modeling, analysis and applications. So, if we go through all these 40 lectures, you can see that most of the relevant theories, principles, modeling, all these things were covered in these 40 lectures. Then the main aim of these lectures were to demonstrate how these fundamental principles, theories are used in the field of watershed management. So, this has been done by showing a number of case studies as you can see in these lectures. And we have discussed the various aspects of watershed and its management. So, like integrated watershed management approach, then river basin management approach. So, all these aspects were covered in these 40 lectures. So, as I mentioned, there were 40 lectures in this video course presenting the concepts, theory, applications and various case studies. As I mentioned in the first lecture, the course, the main purpose of the course is to discuss various aspects of watershed development and management. So, we have to see watershed as a scientific area where we can effectively manage various resources like land, water, forest, agriculture, flora and fauna within that area. So, watershed management as we have discussed in this lecture, 40 lectures, various aspects like technological issues, social issues, ecological issues, environmental issues, sustainability, all these aspects we have to look into, and all these things were covered in these 40 lectures. So, the course focus was the technical aspects of watershed management, then perspectives on land and water management, and then analysis of complex issues on water management, and on specific knowledge on issues of water management. And also the use of modern techniques in watershed management were elaborated in various lectures as far as these 40 lectures on watershed management are concerned. So, the course module there, so actually the course has been divided into 10 modules. So, here the modules as I have shown in the first lecture, also here again the 10 modules what we have covered in these 40 lectures. So, the first module was introduction and basic concepts, 3 lectures were given. Then second one was sustainable watershed approach and watershed management practices, 4 lectures were given. Then integrated watershed management, 4 lectures were given. Then fourth one was watershed modeling, about 7 lectures were given, and then social aspects of watershed management, that include 3 lectures. Then use of modern techniques in watershed management, that include 5 lectures. Management of water quality, so that module include 4 lectures. Then stormwater and flood management, that module include 4 lectures. Drought management, and this module include 3 lectures. And water conservation and recycling, which was the last module, and that also have 3 lectures. So, that way this video course have got 40 lectures, and then all the aspects of watershed management have been covered in a very systematic and comprehensive way. So, finally, to conclude, so here the main aim what I was projecting was the importance of watershed management when we are looking for watershed management, or when we are going to implement the watershed management perspectives. So, we have to go for appropriate planning, appropriate say management perspectives. So, as I mentioned in many of my lectures, we have to approach watershed as in a holistic way. It is not only the resource like land, then water or the minerals or the vegetation, all this, but we have to see that everything, not only the people in the area, but the various resources, we have to go in an integrated way, and we should go for a holistic approach as far as watershed management is concerned. So, that way this course, the different aspects and different approaches have been elaborated in a systematic way, and all aspects of watershed and related issues were discussed in these 40 lectures. So, as far as the theoretical aspects of watershed is concerned, I have covered the theoretical aspects in the best possible way within the various modules which I have shown in the last slide. So, for each lectures a number of case studies were presented. So, that way this will be very useful to the students and teachers and the practitioners. Then tutorials were given, self evaluation questions, assignments, unsolved questions, all these are provided at the end of each lecture. So, that way this video course will be very useful for systematic study of the watershed management, say for a student or for a teacher or for a practitioner or an NGO who are looking to this video course on watershed management. So, finally, say this course will be useful to the students on say bachelor level, masters and PhD levels, say from civil engineering background, agriculture, geography, geology, resources, environmental engineering, humanities, management, etc. So, that way the syllabus required for each of these specialization I have covered in an elaborated way, as you can see the topics given in each module. So, we can go through a module wise also, you can go through the lecture and then get the various aspects for that particular module. So, the course will be also useful to teachers who are teaching the subject either watershed management or water management, or say various issues related to water as described in these 10 modules, in these 10 modules what I have already shown in this slide here. So, then say also this video course will be useful to NGOs, field engineers, practitioners, scientists, policy and decision makers, government agencies, and for all working in the area of watershed management. So, that way I have planned this video course. So, this 40 video lectures will be very useful to those who are going to work in the area of watershed management, or those who are want to study the topic on various topic on watershed management. So, before closing this video lecture, so I want to acknowledge the following people who were helpful to me to make this video course possible. So, first I would like to acknowledge some of the possible reviewers of this course, Professor S.G. Joshi, Professor Anupam K. Singh, Professor V.R. Desai, and Dr. Vinod Kumar, who agreed to review course videos, slides and materials. Then say many of my students have contributed say as far as the slide preparations are concerned. So, I would like to specifically mention some names like Mr. Harshvin Nunna, Ms. Vardhini, then Dr. Meenal, and then Mr. Anand Kulkarni, then all my former MTech and PhD students like Dr. Vengal Reddy, Dr. Shahapure, Dr. Geeta, Dr. Sahu, and all others. So, many of the case studies say which they have done for their masters and PhD thesis I have included in this video course. So, I am very thankful to all these students. Then I am very thankful to all the CD staff of IIT Bombay. So the excellent recording, and then the excellent facilities, and then also editing, which they have spent a lot of time, and they are very dedicated staff, say, who have made this video in a very excellent form. I am very thankful to them. Without them, of course, I cannot do anything as far as this video course is concerned. So I am very, very thankful to them. And finally, I am thankful to my family, my wife Dr. Manjush, and my kids Aipa and Basil. So I have spent so much of time to prepare these lectures. So for their moral supports, I am very thankful to them. So finally, with a big thank, I am finishing this video course. Thank you very much.